So I know that the integral from a to b of f of x dx is equal to the antiderivative of b evaluated at b minus the antiderivative evaluated at a. But I was just struggling to figure out, like, why is big F, why is the antiderivative the area? I couldn't quite figure it out. I know that I mean I certainly accept it, and we all know how to do it, but a good understanding of why was escaping me. So I kind of went back to the Fundamental Theorem of Calculus Part 1, application of which is not too complicated. So if I have an integral from some fixed point A to some variable x of some function f of t dt, and I take the derivative of that with respect to x, what I'm going to get is the function f of x. I'm going to get the integrand. So just for example, if I was to do the integral from a to x of 2t squared plus 3t dt, that would equal just the function. I'm taking the derivative of this. The derivative with respect to x of this would be equal to, come on now, 2x squared plus 3x. So the derivative of the integral is the function. And again, that's easy enough to accept and certainly easy enough to apply for the most part, but it wasn't giving me the understanding that I wanted. So I tried taking a little bit deeper look, and I made myself a graph, and I made myself a function, and I said, well, here is point A, and then over here is point X, and then I'm making this bigger than it would be normally, but I'm adding some. That's the amount that I'm adding. And so the rate of change of this function from A to X, this right here, I mean, as I'm moving along this direction, that is my rate of change. And we know that the rate of change is the derivative. E-R-I-V-T-I-V-E is a derivative. Which led me to think, well, any function whose derivative is f of x, I decided to type it. Any function whose derivative is f of x, like big F of x, the antiderivative, is the integral. I kind of made a little shorthand by, by saying if I'm starting with an integral, a to x of f of t dt, and I take the derivative of that, derivative with respect to x of that, I know that is equal to f of x, and the antiderivative of f of x is big F of x. And again, since I know that the derivative of big F of x is equal to f of x, that's the same thing as saying the derivative of the integral is equal to f of x. So big F of x is equal to the integral. Just once again, because the derivative with respect to x of big f of x is equal to f of x, and the derivative with respect to x of the integral from a to x of f of t dt is also equal to f of x. So these two things are the same. And that helped me understand it more deeply. It also made me appreciate the Fundamental Theorem of Calculus Part 1 a lot more than I did previously. I kind of think the Fundamental Theorem Part 1 is the basis for the Fundamental Theorem Part 2.